going to do a quick little addendum, which I'll be attaching to the previous, the video that you're going to be just finished watching. It's a little longer, so I just wanted to show that we're still stabilized out here at about 64 milliamps at about 12.6 volts. And I was going to do a quick RPM reading, just because it's been running for about 10 minutes now, roughly, a little less. Switching hands here. Oop, come on, baby. As you can see, we're pretty darn close to 3 grand on the RPMs here. 2985. The first time I ran it, and I do have a video of this, which will probably be posted as well. It's a longer one, which I might have to edit down. I had it up to 3600 plus, about 32, 36, 30, something like that. And it was a power calculation, gave me just a squeak over 1 watt for power consumption, according to the meter numbers. We'll do another one right here with the cell phone calculator real quick. 0.064 times, let's just round it up to 12.6 times 12.6 volts, and that gives us, look at that, I don't know if you can see that, it's a little bright. Focus, no, I don't think you can see it. Anyways, it says 0.8064 milliwatts. So it seems I'm doing maybe just a little better than the last time I ran this thing, because I was using a watt, but I was getting more RPMs out of the baby. Let's see if we, once this load on here, we're going to do another drag test with my fingers. Yeah, of course, current goes up. So this machine is not doing the same thing as the 12 banger or the 8 banger. Now what? The only thing I haven't done here too is also add the computer, the little 12 volt computer fan as an extra load. So we'll do that right now. I'll put that there. That there, and switch it over. Oops, sorry about that. Get the subject matter going here. The fan's not running, but we add that inductive load in there, our resistive and inductive load, and our current went up about 4 milliamps, and our motor did not change its speed at all, and this fan will not run. But what I'm going to do here is disconnect the lights and just connect the fan directly into the power rail, and of course now it really wants to run, and our current just jumped, and our speed's going to go up. Our voltage dropped. So isn't that interesting? How the different kind of load computer fan here made such a difference. It's really jumped in current draw here. Let's just do a quick little calculation on that quick calculator here. Let's just call it 153.153 times 11.7 volts. And 7 volts, and that gives us 1.8 watts. 1.7901, 1.8 watts. Now let's take a RPM reading here and see how much increase in speed we've got. go. Gotta switch hands here. Causing a shadow. You're not going to see the meter. There we go. There's that 3600 number I was talking about. 3630. Exactly what I said on when I started this thing here. Alright, so back around to this side here. Turn this current meter on again. See where we're at. Yeah, we're stabilized at about 153. So we're looking at, what did I say, 1.8 watts, 3600 RPMs, and we're running this little computer fan, and it seems like it's running pretty good. Just put a drag on that, and the current meter goes. And goes up, yep. So, it's pretty much behaving like a pretty standard DC pulse motor. It'll be interesting. I'll just do a quick check to see how much voltage is being generated here from the, or passed on, induced from the secondary windings here. We got, wow, only 7.2 volts. It's running this little fan pretty good for, considering it's a 12-volt fan. Anywho, that's it for the quick little addendum, and it wasn't so quick. Sorry about that. Anywho, next step, full bifelar mode. See what kind of improvement we can get in that department. Bye-bye. Oh, do a selfie.